In 60 seconds, a Panther tank went airborne. Not hit by another tank, not dragged into a ditch by a mine, but lifted and flipped by a falling mountain of metal and fire that came from the sea. It was the dawn of July 7th or 8th, 1944, in the Bocage country east of Caen. The fields were a patchwork of hedgerows and sunken lanes, an armoured maze where stone banks and mature trees turned armour into a blunt instrument. Here, the 12th SS Panzer Division, made up in large part of teenagers recruited from the Hitler Youth, had dug in behind farm walls and narrow lanes. Their commander, Kurt Meyer, had a reputation for aggressiveness and confidence. He believed terrain and armour together made his positions safe from the kind of long-range naval fire the British could bring to bear. From Meyer's point of view, the problem was practical and familiar. Bocage favoured defence. A tank could not simply drive straight ahead. Fields were sectioned by waist-high stone, hedgerows that stopped engines and blocked sightlines. Infantry could hide and fire from small elevations. Field guns, 25-pounders and similar pieces, could support assaults, but in this tangled country, indirect fire often blanked against revetments and dense terrain. Naval guns, powerful as they were, seemed a distant threat when positions sat miles inland and when high elevation for the ship's guns appeared limited by the ship's own design. Meyer placed his Panthers where he could command the approaches and, he assumed, be out of reach. For the British, Caen was an obsession. The city's capture mattered politically and operationally. After weeks of costly fighting, Operation Charnwood was planned to secure the northern approaches. Part of that plan was to use the Royal Navy's heavy guns to shape the battlefield inland. The weapon called on for the task was an improbable answer to an apparent arithmetic problem. The battleship HMS Rodney, a capital ship mounting 9 16-inch guns, could hurl shells with a mass and kinetic punch-field artillery simply could not match. But raw weight of metal was not the only issue. Range and elevation mattered. To get those 16-inch shells to places like the Bocage required more than simply pointing the barrels toward the horizon. The trick the British used was low-tech in concept, brutal in effect. The captain of the Rodney took on extra water in specific ballast tanks, deliberately heeling the ship to one side. By listing the vessel, the forward turrets could be trained at a slightly higher elevation than they would under normal trim. A few degrees might not sound like much, but for a gun that sends a shell hundreds of times heavier than a field piece, those degrees translated to miles. The Rodney's fire control room, an analog mechanical computer the size of a small room, full of gears, cams and plotting tables, recalculated range, drift and time of flight for the new elevation. Observers on the coast and forward control parties adjusted and verified. The mechanics were old-fashioned and precise: weight, angle, ballistics, timing. Then the orders came. The gun crews worked with practice speed. The turrets cracked, powder burned, projectiles left steel casings and rushed into the thin morning sky. From the German lines, it began like any other barrage. The distant concussion of guns you can feel before you hear them properly. But what followed was a peculiar interval, an almost expectant silence stretched by distance and by the flight of large shells on high arcs. The men in the Bocage had time to track the arc. The shells rose. They hung, distant and tiny against blue. Time stretched. 60 seconds is a lifetime when you know something large is about to arrive. 45 seconds. The top of the arc, the thin air cold. 50 seconds. Nothing you can do now will keep you safe from where this weight will land. 60 seconds. The descent. They hit like the earth splitting. The first salvo landed beyond the hedgerows and sent up a cataract of soil. The blast wave rolled through the narrow lanes and punched lenses out in barns and the small glass in windows. Stone hedge banks shattered into a spray of masonry and splinters. Craters formed the size of small ponds. Walls that had seemed impenetrable were unzipped by the pressure and fragments. The air shook. Sound seemed delayed, and then rushed in a single violent sweep, a crushing, abrasive noise that ripped at eardrums and sense. And in that chaos, a Panther, 40 to 50 tons of armor and machine, was flipped on its turret and tossed like a child's toy into a shallow crater. The image is almost absurd if it were not so terrible. Tracks thrown skyward, the suspension unloaded in a sudden obscene release, the hull turned over as if the earth had taken revenge. Kinetic force that large did not merely dent metal, it dismantled geometry. A machine designed for flat advances and positional fighting found itself airborne for a fraction of a second before it slammed back down, broken and useless. Inside the hull, crewmen were stunned and disoriented. Some survived, some did not. In the immediate moment, survivors staggered outward, faces dazed, ears ringing. Others were trapped beneath twisted steel. Reports from that morning described soldiers staring skyward, shaking their heads at the sight. The sky fell, some said in later recollection. Radios ground from static, command nodes splintered. Communications, always fragile in hedgerow warfare, failed. The unit that had seemed cohesive and ready 1 minute was fractured the next. What happened in those 60 seconds was not mystical. It was arithmetic and physics, applied with ruthless creativity. The Rodney's shells followed high, looping trajectories. They reached terminal descent angles, steep enough to deliver vertical shock to targets previously defended by lateral obstacles. The blast wave, pressure radiating outward from a close detonation, did not respect stone walls built for line-of-sight defense. Where a hedgerow could stop bullets or obscure sight, it offered no shelter from a column of air and shrapnel descending from above. The tactical consequences were immediate. Tanks immobilized by damage or buried by debris could not be moved. Maintenance crews were too small and too exposed to repair them under fire. Supply paths skeletonized by crater fields became death funnels. Infantry, accustomed to working in the cover of hedgerows, found those places transformed into traps. Commanders lost direct control, as runners could not cross the torn-open ground, and radios suffered from blast-damaged aerials. The cohesion that made defensive doctrine effective, the ability to coordinate counterattacks, to move reinforcements into threatened sectors, evaporated. There was also a psychological arithmetic. These were not hardened veterans alone. The 12th SS had many young men whose indoctrination and training had convinced them of invulnerability in certain terrains. They now witnessed their machines, the concrete centerpieces of their confidence, rendered impotent from a source they thought irrelevant. Shock, blank disbelief, then fear spread faster than any shell. The moral effect was that a single bout of concentrated long-range fire could break a unit as effectively as many costly close-quarters assaults. Wider strategic consequences radiated outward from that moment. A Panther represented much more than a single vehicle on a battlefield. It embodied skilled labor, scarce raw materials, intricate machinery, and a production process that took time and resources. Replacing a wrecked Panther was not a matter of a few days. It meant weeks to months of industrial input. By contrast, shells and smaller, cheaper tanks could be produced in far larger numbers and at higher tempo. The Royal Navy and home industries could manufacture and supply the means to lash out repeatedly faster than German factories could replenish hard-won armor. In a contest of attrition shaped by industrial throughput, sheer quality could be outrun by relentless quantity. This was the core lesson of that morning. Tactical craft and battlefield ingenuity, even ferocious bravery and technical competence, could be overwhelmed by a different kind of competence, the ability to put massed firepower where it mattered, to reconfigure platforms to reach new targets, and to sustain such fires over time. The Rodney captain's decision to list the ship was not a moment of genius so much as a pragmatic exploitation of available means. A small engineering change multiplied by the ship's existing destructive capacity. It turned a physics problem into an operational solution. If this seems an arid, mechanical reading, consider what the math implied for the men on the ground. A single salvo could remove several fighting vehicles. Several salvos could hollow out a defensive sector. For every Panther knocked out by long-range fire, a factory might struggle to replace it while dozens or hundreds of shells were expended. The calculus was unforgiving. The defenders' local tactical advantages were increasingly irrelevant when the attacker could bring down ordnance in volumes and from angles previously unavailable. Kurt Meyer saw this war in human terms and wrote of it later in the blunt language of command. He recognized that modern combat had become less about individual initiative and more about the logistics that underpinned operations, the coordination of ships, guns, factories, and transport. In his memoirs, he would suggest that warfare had been reduced, in uncomfortable fashion, to coordinates on a map, a clinical phrase that captured the depersonalized nature of much of the fighting by mid-1944. Those coordinates could be targeted from thousands of yards away, transformed by waves of metal and explosive, and then erased from the map. The image of a panther flying for a heartbeat is therefore both literal and symbolic. Literally, it was the result of heavy ordnance meeting a soft target at close range. Symbolically, it marked a turning point in how battles were won and lost. The old notion of the duel, man against man, tank against tank across open ground, had to compete with massed industrial capacity, naval firepower, and the logistical networks that sustained them. The battlefield was no longer only about who fought better, but increasingly about who could produce more, move more, and aim more precisely with the means at hand. There are deeper implications for command and doctrine. For German planners who relied on terrain and quality of armor to offset numerical inferiority, the new reality posed a moral and intellectual challenge: adapt or risk annihilation. Adaptation required resources, technical fixes, dispersed basing, improved camouflage and counter-battery measures, and in some cases, strategic withdrawal. Many of those options demanded time Germany did not have. Meanwhile, Allied forces had demonstrated a willingness to fuse naval and land fire, to combine platforms in ways the Germans had not anticipated or could not counter effectively at scale. The cost in human terms remains sobering. Machinery can be replaced, men cannot be easily remade. Yet even here the industrial dimension returned. Replacements for personnel, new recruits and conscripts were supplied in larger numbers than competent veteran cadres could be trained. The psychological damage of seeing heavy armor, rendered useless, however, had effects on morale that single replacements could not immediately fix. Units that broke in the face of massed fires became operationally unusable, compounding supply and production problems with immediate battlefield losses. So what does the Airborne Panther tell us beyond a single dramatic image? It tells us that warfare in the modern age is a contest of complex systems, logistics, industry, and the creative application of engineering tweaks as much as frontline tactics. A battleship's ballast tanks and an analog fire control computer were as decisive in that hour as the Panther's sloped armor. The battlefield was a spreadsheet of possibilities, where the enemy would strike, what resources they could bring, and how quickly you could recover. It was impersonal, efficient, and ruthlessly pragmatic. The story of the Rodney and the 12th SS on that morning also highlights a subtler truth about innovation in war. Cleverness often comes down to recognizing an asymmetry and exploiting it cheaply. Listing a battleship required no new invention, just a willingness to accept temporary risk to achieve a new firing solution. The staff officers who authorized the idea were not seeking heroics, they were seeking effect. What cost them little produced results that cost the Germans dearly. That is the lesson that echoes into military thinking today. Sometimes the smallest technical or procedural change, multiplied by the scale and reach of existing systems, will have outsized consequences. The Airborne Panther is an emblem of that dynamic. It is not merely a photograph in a logbook. It is an argument against assuming that tactical skill will always overcome strategic weight. As you picture the tank arcing through the air, remember the layers beneath that image, the geometry of hedgerows and lanes that lured commanders into a false sense of security, the ship's captain calculating list and angle, the mechanical brain in the fire control room recalculating ballistic tables, the shell's long, patient flight, and the 100 small decisions that led to an instant of devastation. Each layer matters. Each layer was a choice made by humans operating in systems of production, command, and constraint. What might have changed if Meyer had dispersed his forces differently? If camouflage, counter-battery suppression, or mobility had been emphasized over static holding? These are valid tactical questions. Yet the broader answer points back to capacity. To shift the balance required not only doctrine, but an industrial baseline capable of producing the alternatives. And on that score, by mid-1944, the balance for the Normandy campaign favored the Allies. One morning, in that hedgerow country, a machine of war designed to dominate land found itself dominated by a different set of machines, operating from the sea and the factories that supplied them. The photograph of a panther, flipped onto its turret, captures the pity and the meaning of that moment. It is shocking because it makes visible what strategy and industry can do when they are combined with audacity and technical competence. If this narrative resonates, consider the wider pattern. Throughout modern military history, moments of tactical brilliance have been countered by innovations in logistics and firepower. The Airborne Panther was a dramatic expression of that pattern. It was a collapse of confidence in an instant and a reordering of the battlefield that had already been gathering for years. Before we go, if you enjoy tactical and operational breakdowns like this, and you want more analyses of how technology and logistics shape battles more than individual heroics, like and subscribe. It helps us bring more detailed episodes like this to you. Finally, think about this. Could superior tanks and defensive cleverness have held without naval gunfire being brought to bear? Or does the Airborne Panther show that in industrialized war, the question is less about isolated superiority and more about systems of production, transport, and the creative use of available tools? Tell us what you think in the comments below, and if you want a deeper dive into naval gunfire and ballistics in Normandy, watch the next video where we map shell trajectories and ship gunnery against inland targets.